Hi, in this video we'll explain what the Euclidean algorithm is and how it works. The algorithm is named for this guy, Euclid, who invented this and a whole bunch of other math. The Euclidean algorithm is a very efficient way to compute the greatest common divisor, or GCD, between two numbers. This means the result of the algorithm will be the largest number that evenly divides both of the input numbers. For example, the GCD of 20 and 8 is equal to 4 because the only numbers that divide 8 are 8, 4, 2, and 1. And the largest number that also divides 20 is 4. The basic idea of the algorithm is actually pretty simple. For some inputs A and B, we take away the smaller from the bigger until the bigger one is less than the smaller one. This is one iteration, and we repeat this process until we hit 0. The smallest non-zero number we get is the greatest common divisor. As an example, if we want the GCD of 20 and 8, we subtract 8 from 20 until we get a smaller number than 8. 20 minus 8 is 12. 12 minus 8 is 4. And now we repeat with 8 and 4. 8 minus 4 equals 4. 4 minus 4 equals 0. That means 4 is the GCD of 8 and 20. Now, you might see the algorithm explained elsewhere using the remainder of A divided by B. Using the remainder is just a faster version of the algorithm we described using subtraction. On the left, we're saying that the smaller number b goes into the larger number a, k times with sum a equal k times b plus r. But on the right, we're saying if you subtract b from k times, you'll get a number smaller than b, which is c. Rearranging the expressions, we see that c and r are exactly equal, which means the two algorithms versions that we've described, division / remainder and subtraction, are exactly equal. Let's walk through both algorithms with our previous example. For the GCD of 20 and 8, instead of subtracting 8 from 20 twice to get 4 on the left, we only need a single division to get the remainder on the right, which we will write as 20 mod 8. We repeat this process again, taking 2 subtractions on the left and 1 division on the right. After 2 iterations on each side, we find out that the GCD we want is 4. But why does this work, you might ask? This algorithm works because subtracting one number from the other doesn't change the GCD. To see why, think about each number as a volume of milk. Let's use this milk carton symbol to denote 4 liters of milk. 20 liters is built up using 5 cartons of 4 liters, and 8 liters is built up of 2 cartons of 4 liters. No matter what you do, there's no way to get a fractional amount of milk, or a fractional carton, I should say, by just adding and subtracting the original 2 numbers from each other. It's simply not possible to reach a number less than the GCD using just addition and subtraction. In some sense, we can imagine the GCD of 2 numbers as being the resolution the numbers have in addition and subtraction. If you've ever seen those problems with pouring out 1 cup of milk with only a 5-cup glass and a 2-cup glass, now you know how to solve them. We can illustrate the same idea a little bit more mathematically. Think of 20 and 8 on a number line. Now let's zoom out 4x so that we can actually see the numbers, and so that each tick mark now spans 4 units. 20 and 8 look exactly the same as 5 and 2 did on the previous number line. No matter how you add or how you subtract the 2 numbers, you'll never end up with any lengths less than the tick mark length of 4. If we look back at the normal number line, this is just like saying no matter how you add or subtract whole numbers, you'll never get a fraction like 1/2, because the greatest common divisor for the set of all natural numbers is 1. Hopefully you found this explanation useful, and I hope to see you next time.